Alrighty, we are working on volumes of prisms and cylinders today. So we were on surface area, which is like if you're gonna wrap something, it'd be like the round on the outside part. Volume is what's going on the inside. And cool deal with both prisms and cylinders, we have the same basic formula. Obviously, when you get down to the shapes, it's a little bit different. But to find the volume, we take this big B. Now, what this stands for is the area of the base. So that big B stands for the area of the base. You're still finding area, and then all you're going to do is times it by the height. Obviously, height. So volume, big B, times H. Okay? Now, your base, remember, is the shape that has two of the same shape. They're congruent and they are parallel, so they don't touch. So here you could do like top and bottom would be your base. Here the circles are your base. Circles are always the base for cylinders, FYI. And then the height is what's in between those two bases. Okay. All right. So first we're going to start with this rectangular prism here. And you can pick, to be honest, any sides. You could do, with rectangulars, you can do top and bottom as base. You can do left and right as base, or front and back as base. A lot of times I just do the top and bottom as the base because, like in this instance, those are both labeled right there. So you could do something else too as long as your height is different. But all right, so we got this formula. Volume equals area of the base times height. I chose this to be my base, so the area of that base is 5 by 3. And then the thing that gives it height is this 4. So area of the base, 5 by 3, times it by the height, which is 4. And we get 60 feet cubed. With with volume, we got cubed. Area was squared. Volume, our label is cubed. Guys, I can't talk today. Holy cow. We're not going to do this. Okay. It says volume of the triangular prism. So it tells you your base has to be a triangle. Well, I spot a triangle right there. And then the other one, obviously, back here. Okay. Same formula. Area of the base times height. In this case, my base is a triangle. So I have area of a triangle is half times base times height. Notice I change it to a smaller b. The big B stands for area of the base. This little b stands for the base of my triangle. And this height is just of the triangle, whereas the other h outside is the height of your shape for the volume. Okay, so again, we got the triangle part, half times, if I look at my triangle, remember base and height have to make the right angle. Doesn't matter which one you call base, which one you call height. I'm going to call this 6 my base, and the height of my triangle is this 10. But the height of my shape, the thing in between the bases, is this 5. Okay? So half times 6 times 10 times 5 gives me a total of 150. And then our label, meters cubed. And we're going to skip that one. Okay, so area of your base times height. And the height stands for what is in between the bases. All right. We got this triangular prism again, so I know that the triangle has to be my base. Here's my triangle. And you'll notice it's 8 by 8 by 8, so it is an equilateral triangle, which means all my degrees inside are 60. I need to know, obviously the base of this is 8. I know I'm going to have to find the area of this, right? Because our volume is area of the base times height. My base is a triangle, so half base height times height. Hopefully that wasn't my entire face, or my head, sorry, if it was. Anyway, so my base of my triangle is this 8. So half times 8 times the height I need to find. It's not 8. I have to find it. So I know this angle's 60. I know this side is now 4. So this is a short leg. This is a long leg. This is 4 squared roots of 3. Now the height that's on the outside of the parentheses isn't talking about the triangle anymore. It's talking about my whole shape. So it's going to be this 10. That's in between the two bases, in between the two triangles, right? That 10 is what's in between those two. So this gives me 160 square roots of 3. So if you take 160 times the square root of 3, it gives you about 277.1 inches cubed. So B. Okay. Cylinders get a little bit easier because there's like a for sure formula, because every time your base is a circle, right? So we have this basic formula where volume is area of your base times your height, but with a cylinder, your shape of your base is always a circle. So the area of a circle is always pi r squared, and then h is the height of your shape. So in this case, my radius is 3, so I'm just literally plugging in here. Height of my shape is 8. So this gives me, it says leaves in terms of pi, so 72 pi, and then our label, centimeters cubed. Again, volume cubed. And then again, volume of a cylinder. We got area of a base times height. Our base is a circle, so pi r squared, and then times the height here. Notice that this 2 is a diameter, so our radius is just 1. And then even though this is lopsided, remember height always has to make a right angle. So like here, this 10 makes a right angle here, this 8 makes a right angle with the base. So this 3 is your height. Again, it says leaves in terms of pi, so we have 3 pi meters cubed. So height, even in between the bases, is always perpendicular. It makes that right angle. All right, we're going to do one more. It says the volume of a cylinder is 135 pi centimeters cubed. What is the height is 15 centimeters. What's the radius? So again, when you have a cylinder, it's that standard pi r squared times h, because your area of your base is always the same. So it's telling you the volume is 135 pi. It says your height is 15. So that means I don't know r, but I do know that the height is 15. Okay? So I'm going to divide by this 15 and this pi. So the 15 and the pi. So all that's left over here is r squared. Pi's are going to cancel. 135 divided by 15 is 9. To get r by itself, square root. So our radius is 3 centimeters. We're going to skip this. Obviously, you would just have to find the volume of those separately and add them together. Go do your practice.